Well, in this lesson, our goal is to we're going to leave the whole section of just solving a simple linear equation where we just had that variable, the one variable, it was to the first power. And we're actually going to go now to solving quadratic equations. And the key difference between a linear equation and a quadratic equation is the exponent on your variable. If you start incorporating x squareds into the system, then we're definitely talking about a quadratic equation. Okay, so I gave us an example here to look at, like let's say 2x squared minus 3x plus 4. This is quadratic because the 2x squared term. Okay, and in general, if you want to know, we have this title called the general form. The general form of any quadratic is you throw all your terms on the left side and you keep a 0 on the right, and then you order your terms. You want to go in descending power. So you have an x squared term, then an x to the first term, and then you have, if necessary, if there is one, then you have the term that doesn't have the variable. We call that the constant term. It's always going to be the third one listed. Okay, and before you do any kind of solving, the first thing you want to look at is to make sure that your equation equals 0. So in other words, make sure it's in general form. And then from there you have two options to help solve it. You can either factor it or use the quadratic formula. And I wrote the quadratic formula right there. It's x is equal to negative b plus or minus the square root of b squared minus 4ac all over, here's the key, I'm going to show you this, all of this whole top numerator is divided by 2a. Okay? And obviously the a, if we look back up in general form, is always the term that it's the number in front of your x squared term. Okay, so a is not x squared, a is the number, it's the coefficient that's on the x squared term. B is the coefficient attached to x, and c is just the constant term. Okay. And in general, whenever we're solving a quadratic equation, something to keep in mind is what you're really doing is you're finding the x-intercepts. So if I wanted to come up here and I wanted to graph this, how it's going to graph is a parabola. It's that U-shaped graph. Okay. And obviously if I have like an xy axis, then any kind of parabola can either touch the graph twice, it could touch the graph maybe just once, if that little bump is just sitting right there, or you could even never touch the x-axis. So what we're saying is when you're solving a quadratic equation, what I want you to kind of keep in mind is the fact that we could either get two answers, we can get one answer, or we can even get 0 answers. So in general, just think about this whenever we go through solving. This is kind of what we're looking for. We can either look for one answer, two answers, or not even a single answer. We don't always have to have a solution. Okay? And it's all about this whole visualization of where are these x-intercepts being. Okay? All right, so let's go to example 1. Example 1, they want us to solve this specifically by factoring. So anytime we want to solve, we make sure 0 is on the right, which is already set up for us. And if we look at this one's kind of simple because they've already done the factoring. How do I know that? It's because we're in a product. Remember factoring? In general, let's say if you take 20 and we write it as, instead of 20, we write it as 4 times 5, we've technically factored 20 because we wrote it as a product, 4 times 5. If we go back to this problem, they've already done the factoring for us. It's y minus 3 times y plus 4. So to finish this out, we just set each of the factors, so the y minus 3 and the y plus 4, we just set each one of those then equal to 0. And you can only do this rule, by the way, of setting them, splitting them up and setting them, is if it equals 0. That's the only way we can do that. That's why I made that point above that said you have to make sure your quadratic equals 0 is for this fact right here, because you can only do this property when it does equal 0. If it equals 1, can't ever do that. Okay? And then just finishing solving this out, just move that 3 over. So y is equal to 3, and let's move that 4 over, and y is equal to negative 4. So in this case, it looks like we're getting our two potential solutions. And if I was going to graph this, it looks like we have intercepts, x-intercepts. We're going to cross the x-axis at negative 4 and 3. So something to keep in mind. And over here on the right, if we wanted to check our answer, just kind of like how we were doing with linear equations, we could always plug them in to check our answer. So let's check with y equals 3. Let's check that. So in the first parenthesis, it'd be 3 minus 3 times 3 plus 4. And let's see if we get 0. Well, 3 minus 3 is 0, so 0 times 7 is definitely 0. Let's check 4. I'm sorry, negative 4. So plugging it in, it would be negative 4 minus 3 times negative 4 plus 4. Let's see if it equals 0. Well, negative 4 minus 3 is a negative 7. 4 plus 4 is 0. So negative 7 times 0 is definitely 0. So that one checks out. Okay. Well, that one was pretty simple. A nice way to get warmed up to this. Let's go to the example number 2. Here in example 2, see how it's in general form? It equals 0, so that's great. We checked that off. We need that to happen. But now looking in this form, we need to solve this by factoring, and it's not factored already. So what we got to do is put it into products of this times this, one parentheses times another parentheses. So let's set up two parentheses. They're both equal to 0. Okay. So then we want to lead the front parentheses is with what you multiply to get the front term. Obviously 3x and x is what multiplies to get 3x squared. And what's going to go in the back, we're going to have to do kind of a trial by error. We want the factors of 4, so obviously one's going to be positive and one's going to be negative. Do we go with 4 and 1 or do we go 2 and 2? Okay, well I'm just looking ahead. I know it's going to be 4 and 1 right here, and I need this one to be the positive, and that one right there to be the negative. And just to double check, let's multiply this out. 3x times x is 3x squared. If I do the outsides, 3x times 1 is a positive 3x, but a positive 3x minus 4x is the negative x, and then last will give me my negative 4. Alright, so I know I've got this all factored correctly. So we're going to, because the product equals 0, I can go, alright, 3x minus 4 equals 0, or x plus 1 equals 0. So x is going to be 4/3, or x is going to be negative 1. There you go. And hopefully I didn't go through that too fast. Obviously move the 4 over. In that case, then you would have gotten 3x to be 4, because it goes from a negative 4 to a positive 4 when you move it across that equal sign, and then when you divide by 3, then you'll get the 4/3. Sorry about that. I was just kind of skipping through that real quick. Okay, let's go to an example number 3. Again, with this one, they just want us to practice by factoring. Like before, kind of what we did with linear equations, we don't like fractions. Let's get rid of that fraction. There's only one fraction in there, so it's going to be pretty simple to find the LCD. The LCD is 4. So let's multiply everything that's over here on this left side by 4, and let's multiply everything on that right side by 4. Okay. So 4 times a fourth. Well, a fourth of 4 is 1, so I'll get x squared minus 4x plus 4, because I got to make sure I distribute to everything in there. And then 0 times 4 is still 0. So there's an equivalent equation, and it looks a lot easier at least, in order to factor. So let's go and set up two parentheses. What's going to lead in the front are what you multiply to get the front term, which in this case can only be x and x. What's going to go in the back, since the leading coefficient here is a 1, we can do the factors of the last term that add up to the middle. I couldn't have done that in example 2, because in example 2, the front term was not a 1, it was a 3. But if the leading coefficient here is a 1, then we can do the factors of 4 that add up to negative 4, which is pretty simple, negative 2 and negative 2. So setting these each equal to 0, x minus 2 equals 0 and x minus 2 equals 0, we're really just getting one solution. So I'm just going to box up just one of these. And this is one of those cases where whenever if I want to go graph this, if I wanted to graph this quadratic equation, then what we're looking at is that we just have basically the x-intercept is specifically where that low point's hitting for that parabola. So it's just touching the graph, the x-axis just one time. So getting our one solution. Okay, so example 4. We want to solve another quadratic. Look at this one. We have 8m squared, 64m, but it doesn't have a constant this time. It's still a quadratic. We don't always have to have a constant, but I just kind of want to make that point. You could write it if you wanted in general form. You can say 8m squared plus 64m plus 0 if you wanted to put the constant term in there, but we don't necessarily have to have it. It'll be much easier actually to factor without it. Because when I have two terms and I want to try to factor, first of all, is there anything common I can pull out? Well, between 8 and 64, they have a common term of 8. One's an m squared and the other one's an m, so I can at least pull off the power of 1, and that'll leave me with m plus 8. Well, there you go. You have two things multiplied together equal to 0. So we can say 8m equals 0. Let me write that better for us. 8m equals 0, or m plus 8 equals 0. And just finishing solving this out, if I want to divide by 8, 0 divided by 8 is always going to be 0. Move that over, and we get m to be negative 8. So here's two solutions. And again, if I was going to graph that, what that found was the fact that we're going to cross the x-axis at negative 8 and 0. Okay, now let's go on to example 5. And with here in example 5, what we're going to do for the first part is start something new. Instead of factoring, we're actually going to use the quadratic formula this time. So let's take this equation. We have 2x squared is equal to 8x minus 3. And the same rules apply like we did for factoring, at least to get started, is we can't have all this over on that side. We have to have it equal to 0. So let's start moving these over. Remember, whenever I switch sides, all it does is switch their signs. So 8x now becomes a negative 8x, negative 3 becomes a positive 3, and then equals 0. Okay. So if I wanted to go up there, I'm going to use the quadratic formula, and the quadratic formula says x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. This whole part on the right, all we're doing is working with our coefficients. So let's go to our equation we have, and let's list them off. What does a equal? Well, a is always the number attached to the x squared term. So a is 2. B is always attached to the x term, so that'll be negative 8. And then c is 3. Okay, very, very important. Again, I'm going to reiterate. A has nothing. A is not 2x squared. A is just the 2. It's just the number attached to the front. It's all about just the coefficients. It's as simple as that. Okay, so now we're going to take 2, negative 8, and 3 and plug them in accordingly. So x is going to be negative b, so it's going to be a negative 8 plus or minus the square root of b squared, so negative 8 squared minus 4 times a times c all over 2a, just like that. Okay, so let's keep cleaning this up a little bit. So x is going to equal positive 8 now, because two negatives make a positive, and we have the square root of, it looks like negative 8 squared is 64 minus 4 times 2 is 8, and 8 times 3 is 24, all over 4. Okay, and just working with this some more. 64 minus 24 is 40. And we kind of looked at 40 before. It's not a perfect square, but I know I can break that up into 4 times 10. So let's clean this up. So it's going to be x is equal to 8 plus or minus, well, the square root of 4 is 2. I can pull that out. Square root of 10 can't do much, so it's got to stay inside that radical, all over 4. All right, so I'm kind of working towards my answer, almost done. At this point, what I might want to do is clean this up. And how I decide how to clean it up is I want to look to that front term, what's sitting outside that radical, and my denominator. Do they have anything in common that I can clean up? I can never look inside that radical because that's not really a 10. Remember, it's a square root of 10, so it's like 3.2 or something like that. So between 8, 2, and 4, they're all divisible by 2. So I can take that out and write a 4, take that out and write a 1, and take that out and write a 2. So my overall answer then is x is equal to 4 plus or minus the square root of 10 all over 2. And there is your final answer using the quadratic formula. Okay, now let's take a point. Let's look at this real quick. What is this whole plus or minus thing? So if I really wrote this out, and I'm going to come back and erase it obviously because I'm in the next problem already, but what it's saying is x is really equal to 4 plus the square root of 10 over 2, and then x is equal to 4 minus the square root of 10 over 2. And if I was going to graph, I would go ahead and actually take this and plug it in my calculator because I need to know really what my x-intercepts are. But since we're not graphing, I'm just going to leave it like this. But the whole reason why the plus or minus is we need to get the potential two solutions. Remember, quadratic can have anywhere from 0, 1 to 2 solutions. And this plus or minus part is really helping us find those two potential solutions. Okay, well, let me get some erasing going on, and then let's look at example number 6.